Hi, let's now look at conic sections. So the question that we have says identify and sketch the conic section given by this question that we have here, which is 4x squared minus 4xy plus 7y squared minus 24 is equals to 0. So it's quite obvious we have to rotate we have to rotate all this for us to identify what type of conic we are dealing with. Whether it's an ellipse, a parabola, or it's a hyperbola. So you can also use the discriminant test to identify first hand what type of conic section that you're dealing with. And myself, I like doing that whenever I deal with such questions because it gives me confidence in the answer that I find at the end of the rotation. So all you have to keep in mind is that the coefficient of x squared, okay, it doesn't really matter whether it's positive or negative, as long as it's a coefficient of x squared, it stands for the a. Then the coefficient of xy, which is the b term, and this is what we are trying to eliminate as we are rotating, is the b term, that is the coefficient of xy. This is our b. Okay, then the coefficient of y squared is uh, is represented as c, regardless whether it's positive or negative. So to use the discriminant test, we are going to say b squared minus 4ac. Then what I have here, okay, what I have here, there's a time when this is equals to 0, there's a time when it's greater than 0, and there's a time when is this is less than 0. So what you get here, there is a time when it's equals to 0, there is a time when it's greater than 0, there is a time when it's less than 0. So if it's equals to 0, uh, be rest assured that what you're dealing with is a what is a parabola. So even as you rotate this, what you're going to get, the equation that you're going to, the standard equation that you're going to get at the end is for the what is for the parabola. Then if it's greater than 0, you are dealing with a what with a hyperbola. Okay, you are dealing with a hyperbola there. Then if it's less than 0, you are dealing with what, an ellipse. Okay, so whatever that we are going to get here when you use the discriminant test on this equation that we have there, uh, that's the same conic section that you should get at the end. Okay, because when you rotate, you're going to get the standard equation, and of course there are times when you can get the general equation, and from that general equation you can complete the square, then you come up with you determine your um, you determine the type of conic you're dealing with. Okay, so what happens here is that let's try to say our b, have said we have observed that it's minus 4. So if we say minus 4 squared, then we say minus 4 times a, which is 4, times c, which is 7. So you observe that here is just positive 16 minus, so that's 16 times 7, which is 112. So if you say 16 minus 112, you get minus 96. So you it's quite, you observe to say minus 96 is less than 0, it's negative, and hence what we are supposed to get is what is an ellipse. So at least we know the type of conic that we are dealing with even before we go very far. Okay, so let's go ahead and do the rotation. So what we need to do here is that for us to how to go about the rotation is that you have to know what type of angle that you're dealing with, and again, are you rotating clockwise or counterclockwise? Okay, so what you do is that you can either say to get the angle, you can either say it's you can say cot 2 theta is equals to a minus c divided by b, or you can say tan 2 theta is equals to b divided by a minus c. And in this case, you observe that your a is equals to 4, that's the coefficient of x squared, minus your c, which is positive 7, which is the coefficient of y squared, divided by your b, which is minus 4. You can do the same here. Your b is minus 4, then this is divided by 4 minus 7. So this just gives you minus 3 divided by minus 4. Same here, you get minus 4 divided by minus 3. This is going to give you 4 over 3. So here this is still going to be 3 over 4. So what happens here is that for example, if I use this one to try to come up with the angle, I want to try to see if I'm coming up with angles such as maybe 90 or 60 or 45 or maybe 30 or something, or maybe 128 or something, an angle that I can, some perfect angle that you can work with that does not have decimal places. What I'll do is that I'm going to use tan. So what I'm going to do is that I'll say tan is actually opposite over adjacent, of which our opposite is 4. I say 4 divided by 3. I'm going to get 1.33333. Then if I find what the exact angle is, I say shift tan. I'm going to get 53.13. This is what I get, 53.13010235. So this is the angle that I get there. Okay, then if you divide this by 2, because you're saying 2 theta, not theta, so for you to get the theta you have to divide it by 2. So if you divide that by 2 you get 26 point, let me say 565, I can leave it there, degrees. So this is more like the angle at which you are rotating the conic that you have, and you observe since it's positive there, you are dealing with um, clockwise rotation. But for us to get the actual angle that you're going to use to cancel out the b term, okay, it's considering the fact to say what you have here is not something that is perfect that we can work with. We can use we can use um, half angle identities. Okay, and for half angle identities, you can use them anytime. Okay, you can use them anytime. So what I'll do is that I'll say I've gotten that tan 2 theta is equals to 4 over 3. My 4 is my opposite, then my 3 is what is my adjacent. So if you write a right angle triangle like this, since both are positive, it's going to face like that. So your opposite is the 4 here, then your adjacent is the 3, meaning your hypotenuse, if you use Pythagoras theorem, is just going to be 5, because you're going to say 4 squared plus 3 squared, which is 9. You're going to get so that is 4 squared plus 3 squared, which is 9. You're going to get 25. So that's 16 plus 9, you get 25. The square root of 25 is 5. So it's more like the angle that you have at this point. Okay, the angle that you have there is 2 theta. So now what I'm going to do here is that I'm going to say what is my cos 2 theta now. So cos 2 theta will be nothing but adjacent over hypotenuse, which is 3 over 5. So I'll come and use the half angle identities. So for the half angle identities, you can check them out on the on you can try to look for the trig identities table. So for sine theta, okay, sine theta is going to be equals to it's of course positive or negative, but I'm just going to use the positive part. For sine it's 1 over 2 here, then here it's what, it's 1 minus cos 2 theta. That's why I was looking for cos 2 theta there. So this is the whole essence. Like when you draw up your right angle triangle, all you're trying to do is to find what your cos 2 theta is. Okay, so what is our cos 2 theta? We find that is 3 over what, 3 over 5. So what happens is that you can make this a single fraction, and that would be more like 5 minus 3, which is 2, divided by 3. So it would be more like 1 over 2 multiplied by that would be 5 minus 3 divided by 5, which is 1 over 2 multiplied by 2 over 5. That can go and that can go, and your sign is just equals to what, 1 over the square root of 5, like that, because you're going to remain with the square root of 1 over 5, of which is the square root of 1 divided by the square root of 5. This here just gives you what, just gives you a 1. That's why I've written it like that. Okay, so now let's go ahead and find what the what our cos is, what our cos theta is. So we can say cos theta is going to be equals to 1 over 2. Instead of saying 1 minus, this will be 1 plus 3 over 2. You are still saying 1 plus cos 2 theta. So here you observe to say if you make this a single fraction, it will just be 5 plus this is going to be more like 1 over 2, and that's going to be 5 plus 3, which is 8, divided by 5. 2 here, 1, 2 here, 4. The square root of 4 is 2, so this is going to be 2 over the square root of what, 5. So that's what our cos is. Okay, so having determined what we want, remember to say we said sine theta, we have found 1 over the square root of 5. then cos theta, we have found that it's what? It's 2 over the square root of 5. Okay, so now we have to know the equations that we are using. So considering the fact to say we are given this equation which is supposed to be on the prime axis, like on the original xy plane, but the one that we are going to rotate. So what you're going to what's going to happen is the equation that you're going to use for x and y is that for x you're going to say x is going to be equals to so it's your choice. You can either say x prime, or you can use uppercase x. It's really up to you. So maybe for convenience sake, let me use uppercase x, um, like this, and you are supposed to say cos theta here minus uppercase y here sine theta. Then for y, your y will be equals to um, your y will be equals to uppercase x sine theta plus uppercase y cos theta. Okay, so you need to come here and say, okay, for what am I going to get for x? For x is going to be equals to, so it's x cos theta. What's my cos theta? Is 2 over the square root of 5. We're just going to say 2 over the square root of 5. Then that will be multiplied by x minus, what's our sign? Is 1 over the square root of 5. So just be y divided by the square root of 5. Then your y your y will be equals to, what's your x, what's your sign? Your sign is equals to that, so this will be x over the square root of 5, then plus cos theta is 2 over the square root of 5 multiplied by uppercase y, like that. So this step that we're just from taking here is very 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 important, more especially knowing what equations that you are dealing with. So just to remind you, if this was rotated, then you're trying to bring it back on the prime axis, as I would call it. The equation that you'd use is that you'd have your uppercase x being equals to, what it means is that if I say uppercase x, meaning where there's uppercase x in the equation, the rotated equation, you're going to say your x is going to be equals to that would be your x cos theta plus y sine theta. Then your uppercase y will be equals to minus x sine theta plus y cos theta. So these are what you use if it was rotated. Like when they give you the equation, they tell you it's rotated. This is what you use to determine your what, to determine your more like the equations that the standard equation that you're going to get, that's going to be on the prime axis. That is when the like it's just going to be on the xy plane, like that. If it's an ellipse, it will be like that. But for this one that we are dealing with, it's either it's rotated, maybe it's like that or something, we don't know yet, for now at least. Okay, so this step that we're just from taking here is very very important. So one thing here is that before I even continue, if the angle that you get, if the angle that you get, in this case I got that my tan 2 theta was equals to 4 over 3. I'm not getting something perfect such as maybe 90 or maybe 60, because we can use the special angles to know what tan 60 is. But in this case we have 4 over 3 and we don't know what that is. Then try to use half angle identities to come up with what your sine and your cos is. Okay, so now let's begin the rotation process. So what will happen here is that I'll rotate each of them individually. Not, is it really rotating? Let me not call it like that. I'll expand each of them individually. Okay, then at the end when you put them together, it's obvious you have rotated. So here I'm going to say I have 4 open bracket then x squared. What is my x? My x is 2 uppercase x divided by the square root of 5 minus y divided by divide by the square root of 5 squared is equals to. So expanding this, if you do this step by step, you're going to end up with something like this is going to be 4x squared, but multiplied by the 4 outside, this is going to be 16x squared divided by positive 5. Then this one is just going to give you, so minus y multiplied by minus y is going to be positive y squared divided by 5 multiplied by the 4 outside. This will just be positive 4 um, y squared divided by 5. Okay, then what you're going to do again is that you're going to say this one multiplied by this one then times 2. So it will be like 2, it will be like 2x divided by the square root of 5 multiplied by minus 1, y over the square root of 5. Here you're going to get minus 2 xy divided by 5 multiplied by 2, that's going to be minus 4 multiplied by the 4 outside will be minus 16, so it will be minus 16 xy divided by 5, like that. And that's what you are trying to eliminate here, is the xy term, is the b term that you're trying to eliminate. Okay, so let me try to erase this so that I can utilize that space. So we have determined that the 4 2x over the square root of 5 minus y over the square root of 5 squared is equals to, we have 16x squared divided by 5 plus 4y squared divided by 5 minus 16xy divided by 5 there. So let's go ahead and do the other one, which is minus 4. Then I put my x, which is 2x over the square root of 5 minus y there over the square root of 5, then multiply by my y, which is x over the square root of 5 plus 2 over the square root of 5 by y. Okay, so what do we get here? So for this one, you are going to get minus, if you take it step by step, you're going to get minus 8x squared divided by 5. Then for the y is going to be positive I think that's also going to be positive 8. Okay, that will be positive 8 there. 8y squared divided by 5. Then the other part, how is this going to be? Okay, this is likely going to give you minus 12, because if you multiply this 2x by this 2y, you're going to get something like 4xy divided by 5. Then if you multiply this one times this one, it's going to be minus xy divided by 5, of which this just ends up to give you what, 3xy divided by 5. Then you multiply this positive 3 by this minus 4 here, you get something like minus 12xy divided by 5. Okay, we are getting closer. So now let's do the expansion for the y squared. Okay, so let me try to move this a little bit down. Can put it here, and I think I can just get rid of these guys. I no longer need them. Then I can put this one right here and this one right there. Then I can push this up. Okay, like that. Then let's now do the expansion for 7y squared. So you can say 7, our y, it's x over the square root of 5 plus 2 over the square root of 5 y then squared. This is going to be okay, how is this one going to be? So this is supposed to be 7x squared divided by 5. Then this will be plus so squaring that one, you're going to get, it's supposed to be 4y squared, but by 7 that would be 28 y squared divide by 5. Okay, then here we are going to get plus 28. So plus 28 xy divide by 5. How I came up with this is that I just said x multiplied by 2y I got 2xy multiplied by 2, or like I add it again, like I'm going to get 4xy by 7 outside. You're going to come up with that. You can try to do it step by step, you still get the same thing anyway. Okay, so there we have it. Then now this one I can push it a bit up like that. Then you observe that if you look at, oh wait, seems I've forgotten something. There's a 5 down here. Okay. So looking at what we have now, we have, let me see if I'm able to cancel out the b term, which is the xy. So I have minus 16. I'll say minus 16 minus 12 plus 28. I get a 0. So that and that and that goes, and it makes me confident because it's obvious I've gotten rid of the b term. So like part of the job is done. Okay, so if I look at adding this one and this one, let me see what I'm going to get. I have positive 16 minus 8 plus 7. I end up with 15. So I'm supposed to say 15 x squared divided by 5, but I can simplify to myself. I say 15 divided by 5, I get a 3. So this is simply 3x squared. Let me look at the y. So this is plus 4 plus 8 plus 28, I get 40. I'm supposed to say plus 40 divided by 5. Of course, that is y squared, but 40 divided by 5, it's 8. Okay, it's 8. So this is 8y squared. I'm supposed to say minus 24, but I'll say is equals to 24, which is this 24 here. So what you do to make this a standard equation, divide both sides by 24, then 24 there, 24 like that. This turns out to be something that is very cute. So 3 into 3 is a 1. 3 into 24 there is what? 24 divided by 3. So this will be x squared divided by 8. Okay, then have I done the right thing? Okay, yeah, it's 8. Then 8 into 8 is 1. Then 28 into 24 is a 3. So that would be plus y squared divided by 3. This is equals to 1. And there we have it. This is the standard equation of an ellipse. Yeah, and remember, that's what we found when we used the what's that thing called, the discriminant test, to try to give us a picture of what we are dealing with before we even continue. And this is what we have. Yeah. Okay, let's go ahead and find everything else that this question was asking for. The question was asking us to do the sketching. So one thing that I notice here is that this is my a squared and this is my b squared. Wait, this is actually on the x-axis. On the x-axis, the rotated x-axis actually. Then let me find everything else that I need, that such as the vertices, the co-vertices, the what else? The focus. Yeah. So let's see now what we are going to get. So considering the fact that a is greater than b, is on the rotated x-axis. Okay, like on the, it's supposed to be, if it was on the prime axis, it's supposed to be on the, like it's supposed to place it like horizontally, more like, but of course it's rotated, but you still be along the x-axis, the rotated x-axis. And you should remember this is the angle and rotating clockwise. And please don't draw it on the prime axis, show it the way it is, like it's rotated. So I have to find my vertices, and my vertices for the v1. So let me just say for the vertices themselves, let me say v1. I'll say v1 is supposed to be, since I'm on the x-axis, it's supposed to be a plus h comma k. Okay, then my v2 is supposed to be, um, in fact, let me write this a bit different. Let me write it as h plus a comma k. That's much better. So v2 is going to be h minus a comma k, because v initially, like the vertices all together, is supposed to be h plus or minus a comma k, like that. Okay, so now let's try to replace with values. One thing that I observe here is that my value of h and my value of k is 0, because this is centered at the origin 0 comma 0. That is what the equation tells me. Okay, it's not always the case. Sometimes if you find that you had maybe a constant term, such as maybe you had like maybe 7y plus 4x, something like that, it could have meant you have to complete the square. You have to complete the square for you to come up with your standard equation. Then from that standard equation, you observe that in some cases, in most cases actually, it's the not the vertex, the center for the ellipse. If you're dealing with an ellipse, if it was a parabola, it could have been the vertex. Then so you can say v1. So considering the fact that a squared is equals to 8, meaning our a is equals to the square root of 8, positive or negative. Okay, so this is just going to be equals to positive or negative 2 root 2. I've just simplified this. Why? How have I done it? It's simply because square root of 8 is nothing but 2 multiplied by 4. And you can write this as in the square root of 4 multiplied by the square root of 2. The square root of 4 is a 2 here, so that's how I've come up with that one there. Okay, so here I can put the square root of 2. In fact, I think let me change the signs here. There's no harm. I'll put this as a minus, then I'll put this as a plus. Okay, so meaning for this one here, our v1 is supposed to be minus 2 root 2 comma 0. Then our v2 is supposed to be 2 root 2 comma 0. So those are the coordinates for the vertices. So let's try to find the coordinates for the co-vertices. Then after that we look for the focus. So for the co-vertices, these are, since this is on the major axis, the co-vertices are supposed to be on the minor axis. So I'll just say CV1. I'm supposed to say h comma b, no, h comma k plus or minus, let me use minus, just minus b here. So meaning my cv2 is going to be h comma k plus b. So considering the fact that b squared is equals to 3, so meaning b is equals to positive or negative the square root of 3, of which I can say my cv1 will be 0 comma, what's my k, it's also 0, minus b, what's my minus b is the square root minus the square root of 3. Then my cv2 will be 0 comma positive the square root of 3. So I can place them there. So let me look for the focus. So for the focus, I will say my f1 is supposed to be at h minus c comma k. Then my f2 is supposed to be at h plus c comma k, like that. So what's our c? So to find our c squared is equals to a squared minus b squared. So c squared will be equals to, what's our a, 8 minus b squared, which is a 3. So c squared will be equals to 5, and so meaning c is equals to positive or negative the square root of 5. So this will be f1 uh, minus the square root of 5 comma 0. Then f2 will be the square root of 5 comma 0. Okay, and we have everything that we need, including the angle actually. So this seems to be a bit long. It's simply because I'm answering while explaining, but when you do it yourself, this will be much easier. You even be much faster because you won't have to explain to anyone. So yeah, it's just like that. So now let's do the sketching. So the prime axes are like this. This is what we have like that. This is the original axis. Okay, this is our x and y. Then we have to determine what our the uppercase x and uppercase y is, how it's going to be. So what we do here is that let me use a different color. So I'll say, so let's just say for example, okay, I can kind of like estimate how my angle can be. So I have to pass through the center there like that. Then whatever line that I put that passes at this point, like at that point, has to be at a right angle. I mean at a 90 degrees angle with this one that I've put. So let me see if I can do something better. Okay, yeah, it's okay like that. So this is what I have. So meaning this is my capital Y and this is my capital X there. So this angle that I have right here, this is my 26.56, let me say 57 degrees. Okay, so now let's plug in everything that we have to. So for the core vertices there, it is 0 comma, if you say the square root of 3 is actually 1.1, so you have like 1 at negative 1.73. Let's say it's somewhere here, and the positive one is somewhere there. Then for the focus, you have 1 at so the square root of 5 is 2.24. So let's say our 2.24, the positive one is here and the negative one is there. Okay, then let's say for the vertices, so you have the square root of 2, which is 1.41 multiplied by 2 is 2.8. So you find that it will be, maybe one is going to be somewhere there, another one is going to be somewhere here. That's where you're going to have your vertices like that. Of course, you when you're drawing on paper, your scale is going to be much accurate compared to mine. Okay, so meaning the sketch is going to be something like that, passing through that point. uh, just a reminder, this will be much better for you compared to mine. Oh my god. Okay, let's see if I can get this right. Not bad. So this is the graph of this equation that we're given here, and that's basically how we go about it. And thank you very much for watching. We'll catch you in the next video.